All right, today's lesson is selective breeding. So let's get into it. Yes, moving on from all this. So like I said, the 4 types of natural mechanisms of mutation, natural mechanisms of evolution, which drive the allele frequencies within a population to change, okay? Only these would naturally occur to change the allele frequencies. Today, we're going to focus on the one that is artificially done, which is basically by humans, right? And remember, these are mechanisms of mutation, mechanisms of evolution, and that is different from speciation. Speciation is basically the end result of continuous evolution that's been occurring, right? So you won't get speciation unless thousands of years of evolution has accrued enough changes in the allele frequency to make it into a different species. So for this topic, we're focusing on the artificial way that alleles can be altered or changed in a population, which is specifically selective breeding. That's the main technique that is used to artificially alter a population's a population's gene pool. So it is considered as a form of artificial selection, where if natural selection is when nature selects for a specific advantageous phenotype, what happens with artificial selection is basically when humans select an advantageous phenotype specifically for ourselves, right? We are thinking about what we need and how we can alter the gene, the alleles within a population to reflect that phenotype that we want. So we basically select or remove particular traits by directly controlling the breeding of animals or plants. So one of the biggest examples that everyone is a fan of are dogs, right? So obviously, dogs started off as their main species is still as a wolf, right? But through artificial selection, we have selected for a particular trait, which is the tameness, which is the how tame can a dog get. By selecting for that one trait, we have given rise to all the dogs that we have now, right? All the dogs we know, not all of them, but most of the dogs we know are bred to be very tame and very responsive to humans because we have selected for those traits within the wolf ancestors that started off, and then eventually we got to the dogs that we know of today. And this can be applied even for plants where we select for a advantageous phenotype that we can see within a population, and we selectively breed those advantageous phenotypes to ensure that the population that arises from them would most likely carry those advantageous phenotypes. So we would basically leave out all the all the disadvantageous phenotypes towards humans, and we would selectively breed those that we find to be advantageous to generate a population that can reflect those alleles, right? So remember, the main difference is that with natural selection, nature is selecting it based on the environmental selection pressures, whereas with artificial selection, humans are selecting it based on what we find to be advantageous or even deleterious, right? Basically, we can also remove particular traits by directly controlling it. In the same way, think about this in terms of the wolf ancestors, right? When we were selecting for tameness in wolves, we were also selecting against aggressiveness, right? We don't want those wolves that are around us to be very aggressive. So we were basically removing those particular traits from those wolves. So getting into it, let's talk about the main differences, right? Like I said, nature is providing for artificial. Wait. That's my mistake right here. This needs to go there, that needs to go here. Sorry about that. All right. So for artificial selection, the humans are enforcing a selection pressure. For natural selection, nature is providing. But otherwise, there's a lot of similarities in terms of their prerequisites, right? they are both a form of selection. So both still require the prerequisites. The first thing is variability. In a population, there needs to exist variation so that even humans can select for the trait that we find to be advantageous, right? If there is a population of sheep and each of them has variation in terms of how much wool they produce, then we can artificially select for the one that generates the most wool because that would be the one that we need. Only because there exists that variation can we select for it. So that's why the first thing is still required. Second thing is the selection pressure, and we discussed, it's artificial for artificial selection. And then third is the selective advantage of the phenotype. Since we are artificially providing a selection pressure, they are suddenly going to increase they are going to get a selective advantage. That specific trait, whichever organism has that specific trait we are selecting for, will have a selective advantage. And then it also matters whether that selectively advantaged phenotype can be heritable to the next generation. So humans induce a selection pressure in the form of directly selecting the desirable traits or removing those particular traits. So a direct example is with the corn, right? So like I said before, when the species of corn, maize, originated, it had very little, that's what I'm looking for, value to humans because the amount we can get from it, the amount of food we can get from it was very little. So we, for many generations, artificially selected for those wild type corn, wild type maize that were generating more and more food. And over many generations, we have created such a different crop because we have basically selected for it for many generations, eventually allowing it to have a lot of food, as you can see, right? So that is one of the abilities of artificial selection, is which we can basically change a population to become however we want it over many generations of artificially selecting for the traits that we are looking for. In the same way that natural selection can do that as well, but the difference is natural selection is responding to the environmental pressures, whereas artificial selection is responding to the selection pressures that humans are inducing, right? So with natural selection, you can see it here. We got two types of butterflies. Obviously, the one that is going to be more visible is going to have a disadvantageous phenotype, and the one that can blend in has a advantageous phenotype. So the selection pressure is the predator, and the advantageous phenotype is having the ability to camouflage. So the one with the advantageous phenotype will have a higher fitness and be able to pass on those advantageous phenotypes. So let's look at selective breeding specifically a bit deeper in terms of those four prerequisites, right? So first we have our variation, and like I said, regardless of whether it's artificial or natural selection, we need that variation so that there is at least one phenotype that is going to be selected for, right? So like I said, a population of sheep, the one that will be generating different amounts of wool, and that's why we can find the specific organism, specific sheep that has the most wool. Okay, that is why we need variation within a population, leading to phenotypic differences. Okay, next is the selection pressure, where we implement an artificial selection pressure upon the population of individuals, and usually this is based on what is the most beneficial or most detrimental to human needs. So if it's most beneficial, we'll select for it. If it's most detrimental, we will select against it. So like I said, the wolves, we were selecting against aggressive traits. For sheep, we are selecting for the one that can generate the most product. So one example is here, right? So you see here, there exists a population of sheep. Some will have a lot of wool, some will have a small amount of wool, and some will be in the middle. That is the variation that exists within a population. And us as humans obviously want want a lot of wool so that we can actually make products out of it. So we will select for those sheep that has the highest amount of wool. That is the selection pressure. We are basically wanting, humans are the selection pressure, and the selection pressure is basically which sheep can generate the most amount of wool. And obviously, this sheep has more wool than the other sheep. So this sheep has a selective advantage in this scenario because humans are inducing that selection pressure. So this sheep will have that selective advantage and allowing it to pass on those advantageous alleles to the next generation due to heritability of the trait. So as you can read, as wool density is a heritable trait, the allele frequencies of high wool density increases over time as only high wool density sheep are allowed to breed. This has been happening with pretty much any type of agriculture or farming, farming, or what's the word I'm looking for? Animal farms, no, growing, basically using animals. We also do selective breeding. We also do it with crops as well. For example, here's another one, right? So if you guys don't know, all these come from the same source, which is, it was a type of wheat. I forgot what it's called. And over time, we are selecting for different traits, right? So for this one, we were selecting for the stem, looking for the stem that has the highest mass. Eventually, we had this thing. Okay. For Brussels sprouts, we were selecting for lateral buds. Eventually, we ended up with a population of lateral buds that look like that. And for this one, for cabbage, we were selecting for terminal buds, and eventually we got to a population of cabbage, and so on, right? Each of these originated from the same plant, but because in different populations, we were selecting for different traits over many generations, they basically became so divergent from each other, right? And that's also something we can do with different plants, right? For example, if we have a virus-resistant plant and a high-yield seaweed, we can artificially select for each to create a selective seaweed, which is virus-resistant and high-yield producing. So we have our variation in the population, we have the selection pressure, we have the selective advantage. So we will facilitate the reproduction between the phenotypes that have the desirable traits, right? So in the same way, we mated the two sheeps with the high wool density. We are basically making sure that those with the desirable traits end up reproducing with each other so that they can pass on that heritable trait into the next generation. So as a result, the frequency of the alleles responsible for the trait will increase in the next generation. So, like I said, a good case study is always going back to dogs because dogs are something that are very closely, let's say, related, but they are basically co-evolved with us over time due to the fact that we basically took them in. So how it started was that wolves were basically hunters on their own, right? They were hunting for their food and they were pack animals. And then humans existed at the same time, hunting for food and were also pack animals. And when we were at camps, the theory is that we had a lot of scrap meat that we would throw around, and certain wolves were able to actually come into those camps and take advantage of the scrap meat that was lying around and actually started to become tame towards humans. Basically they were interacting with humans more and more. And over time, those wolves that were interacting with humans were getting more food, so they were having a selective advantage. And over time, the traits that those wolves had, right, being able to be tame towards humans, those traits were selected for. And before we knew it, wolves were becoming our hunting partners as well. So a relationship started to form where the wolves started to actually uh, coexist with humans because over many generations, those traits that allowed them to do that were passed on to their young over many generations, right? So let's have a bit of a discussion. So basically, in the same way we were selecting for those traits that allowed them to be tame with humans, we were also selecting against any wolves that were not being like that, who were aggressive. We were basically hunting them down or killing them or basically getting rid of them from the population. So selecting against aggressive traits and selecting for traits that would allow them to be tamed with humans, right? So yeah, like I said, phenotypes associated with tameness were present in the population. That is the variation. Among all the wolf population, some wolves were very aggressive, some were slightly tamer, and we were basically artificially selecting for the wolves that were tame, right? And the selection pressure is that we were selecting for that phenotype. The selective advantage is that because those wolves were uh, basically gaining a selective survival advantage, they were able to more likely reproduce. And as a result, the traits for tameness were further passed on to one generation to the next, actually improving that trait over many generations to actually generate the dogs that we see today. All right. So what can happen as a result of uncoordinated selective breeding? So if we took it to an extreme, we were just selecting for one trait, what can happen? Same with natural selection. The problems with continually selecting for a particular trait is that we are eventually going to lose the genetic variation that exists within a population, because we are selecting for a particular trait over time. That trait is the only thing that's going to be passed on, and any other variation within the population will not necessarily be passed on. So for now, let's see here, right? So with humans, selection pressure that favors dark colored beetles, you can see how many dark colored beetles start to emerge after one generation. So you can imagine, after many generations, the only beetles that might exist are the dark colored beetles, which means that genetic variation as a whole would be lowering. And why is that an issue? There's basically two reasons, right? It basically, in general, it reduces the survivability of the population by first increasing the prevalence of deleterious alleles, right? This we talked about in natural selection and also genetic drift, which is basically how, imagine if if founder's effect happened. Why is that a bad thing? Is that when there is only a small population reproducing among themselves over and over, they will pass on any deleterious alleles to themselves over and over, right? Another thing is that there will be lower adaptive potential for the population. So basically, the first thing we need for natural selection or any selection to occur is the variation. So if that variation is already very low, that means that they will have a lower adaptive potential, in the sense that if they face any other selection pressures, they might not be able to survive in that case. So one of the things you can see for life in terms of what are the effects of breeding, selective breeding on genetic diversity, right? So let me first focus on the text part. So imagine the problem with genetic drift, like we've talked about recently. So the problems were that there is a lower amount of genetic variation, and that can cause a lot of issues later on in terms of the kind of deleterious alleles that are passed on. So yeah, rather for genetic drift, that is a random event that's causing it. But for this, it's humans that are causing that to happen. So this is basically a human-caused bottleneck event. Okay, you can call it that. So what happens as a result? This means that there is less genetically diverse gene pools and an overexpression of deleterious alleles. This makes the population as a whole less adaptable and with a lower fitness. And this can be seen with the dogs, right? So think about certain dog breeds that are prone to health complications. This is due to the fact that artificial selection of pure breeds, pure breed dog features is causing them to basically pass on deleterious alleles to themselves, right? In fact, the problem with making purebred dogs is that 1 in 4 purebred dogs is afflicted with a serious genetic problem, right? In fact, you can see this with pretty much most of the dog breeds that you can find. A German Shepherd is prone to all these types of diseases and conditions due to the fact that they have passed on deleterious alleles over and over many generations, and it is going to be expressed in this breed of the dog, right? And the same thing with the pug. So imagine what original wolf skull looked like. Okay, the only reason why a pug's face looks like this is due to the fact of deleterious alleles being passed on, and also humans are selecting for it because we find it cute, so we are selecting for that trait, and that also means that more deleterious alleles are going to be passed on, right? So let's look at this one, right? If a dominant allele is deleterious, of course, natural selection will select against it and remove it from the population over generations. Basically, if that deleterious allele is going to be expressed every time, over time, natural selection will select against it and it will disappear from the population. But the problem is a recessive allele can be passed on without being necessarily expressed. So whether it's beneficial, deleterious, or neutral doesn't matter because it can be passed on without being expressed. So consequently, a deleterious recessive allele can actually remain hidden within a population without being selected against. And this is actually directly the reason why inbreeding is a problem. Even in human populations, we carry deleterious alleles in the recessive form, and we won't really know it. We won't really be bothered by it because it's not being expressed within our within us, so it's not a problem for us. But if you do inbreeding, there is a chance that the person who you are inbreeding with, who are related to you, has the same deleterious recessive allele, and when two recessive alleles are combined, it will get activated, right? So that's why inbreeding is an issue and it's considered dangerous, is because if those two deleterious alleles combine together to become activated, suddenly you have a expression which could be fatal or which could actually give a negative health impact. So we can see that in the skull of the bulldogs, right? In 100 years, selective breeding has changed the English bulldog skull shape. Inbreeding has led to the accumulation of recessive deleterious alleles, which means the most English bulldogs have a respiratory or a cardiovascular issue and pure immune systems and are prone to arthritis. So this is how they were in 1909, and due to the fact that the same breed have been breeded with themselves over and over, more and more deleterious alleles are going to get accumulated, and more of them are going to get expressed, causing it to change the health status of the bulldog itself, causing them to have more respiratory and cardiovascular issues. So remember how we looked at the Amish population and how the fact that when they were breeding within the same population over many years, they started to emerge health issues due to the fact that it's passing on the deleterious alleles. It's the same thing here, just in the population of dogs. Wait. Right. So the second one, which is the lower adaptive potential, why is that an issue? Basically, it reduces their resistance to environmental change. So if you are less adaptable to any selection pressure, you are basically less resistant to any environmental change. And obviously, in the age of climate change, plants actually need to be more adaptable than ever to be able to survive the rapid change in the climate. If they are losing their resistance to environmental change, they are actually at a risk for being going extinct. So as long as the alleles in a gene pool have a high adaptive value for the environmental conditions, the species will be able to persist. More likely be able to persist. However, should the environmental conditions and the resulting selective pressure change, it is unlikely the same allele will still have the same adaptive values, right? So how to put this into context is because we have selected for the trait in corn for it to generate a lot of crops, right? That's the trait we've selected for, and that is advantageous for us, right? But if they have to face any other selection pressure, and due to the loss of genetic variation, they will be less likely to be able to adapt to that selective pressure. And that means that even a single disease could potentially wipe out entire populations because none of the individuals are resistant to it. So none of the variation, there is no variation within the plants where at least one of them is resistant, so most likely they can all get wiped out.
And with being most of the time being genetically modified.
So let's think, corn was never genetically, I mean, I'm not saying never, they probably have genetically modified it by now. They might not have. But either way, selective breeding is not a form of genetic modification because essentially we have not changed the DNA in any way. We have not gone into the DNA and changed anything. We are just artificially selecting for it. In the same way that natural selection is not a form of genetic modification, that is just a natural way of advantageous phenotypes being selected for, and over time that causes the gene pool to change based on that. So what was the question again?
About like you know how some corn are like GMO.
Yeah, that is genetically modified. So if they say GMO, that means something has been changed in the DNA. But if they don't say GMO, chances are it's still being been selectively breeded. Like I said, right? The original corn was a very small strand. So even the non-genetically modified corn were artificially selected for to become high crop yielding corn. Okay. Another thing is that it also reduces biodiversity. In other words, it reduces the genetic variation, right? So basically, selectively bred species are replacing any wild variants. What does it mean by wild variants? Is basically when it emerged for the first time, we call that as a wild type. Over time, when we select for it, we generate different populations, specifically selectively bred species, right? So by only focusing on these selectively bred species, we are basically replacing any wild type variations that existed. And that means we are reducing the biodiversity as a whole. This means that overall, there will be a combined low genetic variation within the selectively bred population. And this actually makes it have a higher risk because like I said, if it has low genetic variation, that means there's a lower adaptive potential. That means that they can't necessarily uh, survive any drastic changes. All right, we're already at the summary. Like I said, this is a very short one. Okay, so artificial breeding basically is human intervention to select the best trait to breed for a beneficial purpose. And remember that it requires variation, heritability, human intervention, and then finally breeding. Okay. Smaller gene pools and overexpression of deleterious alleles can reduce the adaptability and fitness within an artificially selected population. This also means that they are less resistant to environmental changes, their biodiversity, and increase in genetic abnormalities. Any questions? Huh? What do you guys think? Wait, some of the questions out. In the 18th century, farmer Robert Bakewell separated large, fine-boned sheep with long, shiny wool from his native stock to interbreed for future sheep flocks. This is an example of, I mean, the answer is kind of obvious at this point. Yeah. So keywords here, right? separated them, separated two populations, and he interbred the specific ones. That means it is selective breeding. All right. Okay, memes.